Service entrance cable can indeed be installed in 2-1/2-inch plastic conduit, provided that specific requirements outlined in the National Electrical Code, or NEC, are followed. Article 338.10b of the NEC addresses the installation of Type SE cable underground. It stipulates that when Type SE cable is installed underground, it must be encased in a rigid or non-metallic raceway. This raceway must have a diameter of not less than 2 inches. This requirement ensures physical protection of the service entrance cable when it is buried underground, safeguarding it from potential damage due to soil conditions, rocks, or other external factors. Furthermore, Article 338.10d of the NEC provides additional guidelines when Type SE cable is installed in a raceway. Specifically, it states that if Type SE cable is installed in a raceway that is not smaller than 2-1/2 inches in diameter, it shall be supported as specified in Section 334.30 of the NEC. This section outlines the requirements for supporting and securing cables, ensuring that the service entrance cable is properly held in place within the conduit. Compliance with Section 334.30 is crucial to prevent stress on the cable and its terminations, which could lead to premature failure or electrical hazards. There are additional notes to consider when installing service entrance cable in conduit. Firstly, the conduit selected for the installation must be listed for underground use. This listing ensures that the conduit material is suitable for direct burial and can withstand the environmental conditions present underground, such as moisture, temperature variations, and soil chemistry. Using conduit that is not specifically listed for underground use can lead to premature degradation and failure of the conduit system. Secondly, the conduit must be installed in accordance with the NEC requirements for underground wiring, as detailed in Articles 300 and 305. These articles cover a wide range of topics related to underground wiring, including burial depth, protection against physical damage, and proper grounding techniques. Adhering to these requirements is essential for ensuring the safety and reliability of the underground wiring system. Thirdly, a cable must be secured and supported within the conduit as per NEC Section 334.30. This section provides specific guidelines for the spacing and methods of securing cables to prevent strain and movement within the conduit. Proper support is critical for maintaining the integrity of the cable insulation and preventing potential electrical hazards. Fourthly, the conduit should be watertight and sloped to drain any moisture that may enter the conduit. This is particularly important in underground installations where moisture is prevalent. A watertight conduit system prevents water from entering and potentially damaging the cable insulation or causing corrosion of electrical connections. Sloping the conduit allows any moisture that does enter to drain away, further minimizing the risk of damage. Finally, it is recommended to use a sweep elbow when transitioning from underground to above ground. A sweep elbow is a type of conduit fitting with a large radius bend which allows the cable to enter the conduit smoothly and without damage. Using a standard elbow with a sharp bend can potentially damage the cable insulation during installation or when the cable expands and contracts due to temperature changes. In summary, when installing service entrance cable in 2-1/2-inch plastic conduit, it is imperative to adhere to all applicable NEC requirements, including those outlined in Articles 338.10b, 338.10d, 300, 305, and 334.30. Additionally, the conduit must be listed for underground use, installed properly, and designed to prevent moisture accumulation. By following these guidelines, a safe and reliable electrical installation can be achieved. To elaborate on the NEC requirements and best practices for installing service entrance cable and conduit, let's delve deeper into each aspect. Article 338.10b specifies the use of a rigid or non-metallic raceway for underground installations of Type SE cable. Rigid metal conduit, or RMC, intermediate metal conduit, or IMC, and rigid polyvinyl chloride conduit, or PVC, are common choices for underground raceways. The selection of the appropriate conduit material depends on factors such as soil conditions, potential for physical damage, and budget considerations. When using metallic conduit, It is essential to ensure proper grounding and bonding to prevent electrical hazards. Non-metallic conduit such as PVC offers excellent corrosion resistance and is often preferred in environments with high moisture or corrosive soils. Article 338.10d highlights the importance of supporting the Type SC cable within the raceway, referencing Section 334.30 for specific requirements. Section 334.30 provides detailed guidelines on how to secure and support non-metallic sheet cable, which are applicable to Type SE cable installed in conduit. These guidelines typically involve using cable ties, straps, or other approved methods to secure the cable at intervals specified by the NEC. The spacing between supports depends on the size and type of cable, as well as the orientation of the raceway. Proper support prevents the cable from sagging or moving within the conduit, which could lead to stress on the conductors and insulation. When installing conduit underground, it is crucial to adhere to the burial depth requirements outlined in Article 300 of the NEC. The minimum burial depth depends on factors such as voltage, location, and type of raceway. In general, higher voltage circuits require deeper burial to provide adequate protection against physical damage. The NEC also specifies different burial depths for various locations, such as under roadways, driveways, and sidewalks. Ensuring compliance with the burial depth requirements is essential for preventing damage to the conduit system and maintaining the safety of the electrical installation. Article 305 of the NEC addresses additional considerations for underground wiring, including protection against physical damage and proper grounding techniques. The NEC requires that underground wiring be protected from physical damage by suitable means, such as encasing the conduit in concrete or using a protective sleeve. This protection is particularly important in areas where there is a risk of digging or excavation. Proper grounding is also crucial for underground wiring systems to ensure that any fault current is safely conducted back to the source. The NEC provides specific requirements for grounding electrodes and grounding conductors, which must be followed to maintain a safe and effective grounding system. In addition to the NEC requirements, there are several best practices that should be followed when installing service entrance cable and conduit. Firstly, it is important to carefully inspect the cable and conduit for any damage before installation. Damaged cable or conduit should not be used, as it could compromise the integrity of the electrical system. Secondly, it is essential to use the correct size and type of fittings and connectors for the conduit system. Using incompatible fittings can lead to leaks, corrosion, and electrical hazards. Thirdly, the conduit should be installed in a straight and level manner to prevent stress on the cable and fittings. Bends and offsets should be minimized to reduce the risk of damage to the cable insulation. Fourthly, the cable should be pulled through the conduit smoothly and without excessive force. Using a cable lubricant can help to reduce friction and prevent damage to the cable insulation. Finally, the conduit system should be properly sealed to prevent the entry of moisture and debris. Using watertight fittings and sealing compounds can help to maintain a dry and clean environment inside the conduit. When selecting conduit for underground installations, it is important to consider the environmental conditions at the site. Factors such as soil acidity, moisture levels, and temperature variations can all affect the performance of the conduit material. For example, in areas with highly acidic soils, PVC conduit may be a better choice than metallic conduit due to its superior corrosion resistance. In areas with extreme temperature variations, it is important to select a conduit material that can withstand the expansion and contraction caused by temperature changes. It is also important to consider the potential for physical damage when selecting conduit for underground installations. In areas where there is a risk of digging or excavation, it may be necessary to use a more robust conduit material, such as RMC or IMC, to provide adequate protection. In addition to the NEC requirements and best practices, there may be local codes and regulations that govern the installation of service entrance cable and conduit. It is important to check with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. The local electrical inspector can also provide guidance on specific requirements for the area, such as burial depth and grounding methods. By following the NEC requirements, best practices, and local codes and regulations, a safe and reliable electrical installation can be achieved. Installing service entrance cable and conduit requires careful planning and attention to detail. However, by taking the time to do it right, the risk of electrical hazards and premature failures can be minimized. Furthermore, when dealing with service entrance cables and conduit systems, consider the importance of proper labeling and identification. Clearly label all conduits, junction boxes, and disconnects with their voltage, amperage, and function. This practice greatly aids in future maintenance, troubleshooting, and modifications to the electrical system. Use durable, weather-resistant labels that are easy to read and understand. The labeling should comply with NEC requirements for identification of electrical circuits and equipment. Another crucial aspect is ensuring adequate working space around electrical equipment, including service entrance panels and disconnect. The NEC specifies minimum working clearances around electrical equipment to provide safe access for maintenance and repairs. These clearances should be maintained throughout the life of the installation to prevent accidents and ensure that electricians can perform their work safely. Regularly inspect the service entrance cable and conduit system for any signs of damage or deterioration. Look for cracks, corrosion, or other signs of wear and tear. Address any issues promptly to prevent them from escalating into more serious problems. Consider using surge protection devices, or SPDs, to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. SPD can be installed at the service entrance panel or at individual branch circuits to provide comprehensive surge protection. Ensure that the SPD are properly rated for the voltage and current requirements of the electrical system. When making any modifications or repairs to the service entrance cable and conduit system, always de-energize the circuit before starting work. Use appropriate lockout/tagout procedures to prevent accidental re-energization of the circuit. Verify that the circuit is de-energized using a reliable voltage tester before touching any wires or equipment. Finally, it's a good practice to document all electrical work performed in the service entrance cable and conduit system. Keep records of all inspections, repairs, and modifications, including dates, descriptions of the work performed, and materials used. This documentation can be valuable for future maintenance and troubleshooting, as well as for demonstrating compliance with the electrical codes and regulations. By paying attention to these additional details, you can ensure the long-term safety and reliability of the electrical installation. The installation of service entrance cable and conduit is a critical aspect of any electrical system and is essential to adhere to all applicable codes, standards, and best practices. In addition to the points previously discussed, it is crucial to understand the different types of service entrance cable available. The most common types are Type SE Style R and Type SE Style U. Type C Style R cable is designed for above-ground use, while Type SE Style U cable is suitable for underground use. Always select the appropriate type of cable for the specific application. Another important consideration is the ampacity of the service entrance cable. The ampacity refers to the maximum current carrying capacity of the cable. The NEC provides tables that specify the ampacity of different types and sizes of cables based on their insulation type and insulation conditions. It is crucial to select a cable with an ampacity that is sufficient to handle the expected load of the electrical system. Overloading a cable can lead to overheating, insulation damage, and potentially a fire. When installing service entrance cable and conduit, it is important to use proper pulling techniques to avoid damaging the cable. Use a cable lubricant to reduce friction and make it easy to pull the cable through the conduit. Avoid kinking or twisting the cable, as this can damage the conductors and insulation. If the cable is too difficult to pull, consider using a larger size conduit or breaking the pull into multiple sections. After the cable has been pulled through the conduit, inspect it carefully for any signs of damage. If any damage is found, the cable should be replaced. It is also important to properly terminate the service entrance cable at the service entrance panel. Use appropriate connectors and fittings to ensure a secure and reliable connection. Follow the manufacturer's instructions for terminating the cable. Torque the connections to the specified value to ensure good electrical contact. A loose connection can cause overheating and potentially a fire. Before energizing the service entrance cable, it is important to test it to ensure that it is properly installed and that there are no faults. Use a multimeter or other testing equipment to check the voltage, continuity, and insulation resistance of the cable. Verify that the voltage is correct and that there are no short circuits or ground faults. If any problems are found, they should be corrected before energizing the cable. Finally, it is important to keep the service entrance cable and conduit system clean and free of debris. Dust, dirt, and other contaminants can accumulate on the cable and conduit, which can reduce their performance and lifespan. Regularly inspect the system and clean it as needed. By following these additional guidelines, you can ensure that the service entrance cable and conduit system is installed and maintained properly, which will provide years of reliable service. Remember, electrical work can be dangerous. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that the work complies with all applicable codes and regulations.